Thank you for the welcome. This is the, what are we on now, 7th in the series of lectures at various academic establishments about JAM, the Join Accumulate Machine. I'm going to get on because I've got some new stuff, some new material, and I don't know how long it's going to take to show. Good. I'm thankful to Ovi for giving the context with which this talk comes to you. I want to begin by drilling down a little bit on that context. Within the blockchain sort of Web3 industry, we see a growing divide between what we might call the long-term thinking that Bitcoin, to a large extent, but also protocols prior to Bitcoin, really embodied, and shorter-term results that are much more driven by, lesser ideals, I would say. And we've seen some of the things that short-term results result in quite recently with the Bybit hack. I was giving this presentation, by the way, this very same slide, more than 5 days ago, teaching people that maybe it's not such a good idea to emphasize short-term results over long-term thinking. Maybe it's better to have secure, rich metadata when we're signing transactions rather than just assume that the hash is probably fine and sign anyway. And then, yeah, it turns out that 1.5 billion gets nicked because of that. We cannot expect things to be fine if we prioritize short-term results in favor of long-term thinking. They will not be fine. A few practitioners will certainly make off with a nice, tidy profit, but the wider world, the wider industry, the user base, the companies building businesses on these things will not. Polkadot is really at the forefront here in creating software, services, protocols, and products which have the long-term thinking at their heart. Now, these four things are not the same. They're related to some extent, but they're far from the same thing. You know, cryptocurrency is essentially a virtual resource. Blockchain is a technology, pretty much the only technology which we know can implement this in a secure, fundamentally secure fashion. DeFi is a vertical, another use case, if you like, built on much the same technology. But Web3 goes beyond blockchain, and it certainly goes beyond DeFi or any particular use case of it. Web3 is an approach to solving problems. In some sense, you could say Web3 is the basis for building resilient public digital infrastructure. Now, the key difference between Web2 and Web3, in fact, not just Web2 and Web3, but pretty much everything that has come before Web3 and Web3, is that Web3 systems are designed to be resilient. In some sense, they're designed also to be anti-fragile, such that diversity actually improves the system, improves its resilience, makes it stronger. This is in stark contrast to traditionally architected systems, server-client systems, centralized systems, Web2 systems. This resilience has to be against everything, not just a selection of things, including the things that we don't know about yet, unexpected situations. So in this way, Web3 is a revolution in how we interact with the world, how businesses interact with each other, and so on. Now, the main resource of Web3, you might argue, is block space. I'm not actually sure whether it's the only resource. I suspect that we could argue that there are things like secure messaging or authentication systems, or I don't know, digital decentralized storage systems that could also be argued to be a resource of Web3. But certainly the main resource of Web3 is block space. And a quite respected person within this industry reckoned that it was actually a pretty good thing to be selling, reckoned that, this was something that would become a very strong need for. Now, block space isn't just all the same type of stuff. There are various different qualities of block space. Yeah, it has certain properties that we can measure it by. Blockchain is in fact a decentralized computer. That's all it really is, a decentralized computer. Now, a decentralized computer is a bit of an odd thing, because computers, at least the ones that you're probably familiar with, are quite physical. Like, here's a computer, it sits here in my hand. It doesn't sit anywhere else. I can take it with me and make it sit somewhere else, but then it doesn't sit here. A decentralized computer doesn't have a physical form. It's actually just a model. But it's a model that is real in the sense that we can use it, in the sense that it has a definite state. And because it has a definite state, we can give it a sort of name, and we can tell other people that we're using it too. We can deploy software and expect other people to be able to use that software. So it is a single computer. It's just not a single computer that happens to have a body. That's all blockchain is, really. And the fact that it's decentralized is what gives it some of these properties that we like to see, like resilience. Now, history has a habit of repeating itself, or at least rhyming with itself. We see usually, if we look through history, a particular narrative play out as new technologies are introduced. Initially, those technologies tend to be very domain specific because they're there. There was a problem that was economically important enough, economically pressing enough, that new technology had to be invented to help solve it. Yeah? That implies that there was a particular domain, a particular problem that the technology was created for. Over time, that technological advancement tends to be reused or reapplied to solve other problems in other domains. And we end up with a collection of different related solutions, all basically using the same underlying technology. Before long, there generally tends to be a generalization or an abstraction of the technology that allows the very same piece of technology to be used to solve all of these problems. Yeah? This happened with computers. The initial computers were very domain specific. They were basically calculators that were built to solve particular problems, particular mathematical calculations. And over time, the mathematicians that were using them thought maybe they'll generalize them so that they can compute any kind of mathematical calculation. Before long after that, those mathematical calculations got very complicated and turned into basically business services. So this initial invention to generalization is a pretty standard step. Now, one of the other steps that we tend to find is economic commoditization coming after generalization. Once something's general enough, we usually have a few different, very generalized competing technologies. Over time, they tend to converge. And instead of having competing generalized technologies, like, I don't know, probably this is going to fall on deaf ears, but VHS versus Betamax, we tend to converge on a single technology, a single standard, if you like, but with many vendors. Now, blockchain has not yet gotten to that point. But regular computation, regular kind of server-based computation has, and we call it the cloud. We have many different vendors for the cloud, but we can generally choose which one and deploy our software to whichever one that we want. Instead of competing on the specific standard of the industry, they instead compete on relatively smaller differentiators. Blockchain is doing this, right? Blockchain started as a very domain-specific solution with Bitcoin. And over time, it has been generalizing. It's still in the generalizing phase, but eventually we will see some sort of commoditization. Now, one of the sort of steps that blockchain went through was in its journey of generalization was Ethereum. With Ethereum, we aim to take the scripting language, essentially, that Bitcoin had, Bitcoin script, and turn it into a much more general kind of language, a notionally Turing-complete language. Indeed, EVM is Turing-complete, the Ethereum virtual machine language. Now, Ethereum itself isn't very general. It imposes a number of very particular constraints on software developers that want to develop for it. But the language, at least, is pretty general. I mean, it's very nuanced, but it is in some sense mathematically general. With Polkadot, we move things forward a gear, aiming to create what we would call a cloud supercomputer, really trying to commoditize this stuff, create enough of it that is general enough that we could reasonably call it a commodity and allow general software to be deployed into it. So, Polkadot is designed to create the highest quality block space. We can measure this block space, as I said, in a few different ways. One of them is kind of performance or speed, or the amount of computation that it can do, or the amount of data that it can, combined with the amount of data that it can take on. One of the not so effective ways of measuring, slightly gameable way of measuring how fast a block space or a blockchain can produce block space is transactions per second, which you might be familiar with if you know about this industry. Essentially, it's the number of transactions, a number of transfers of funds that can happen that a blockchain system can process per second. In a fairly recent performance benchmark, the production network Kusama, which is built on the Polkadot technology, managed to gain a pretty high transactions per second score compared to most other blockchains, well, indeed all other blockchains. And this was not at full capacity yet. We hope to try it at full capacity at some point in the not too distant future. Polkadot has the highest bandwidth in terms of megabytes per second that it can store and provide. And unlike other blockchains, Polkadot actually does have this as an inherent service that it provides. This actually outperforms domain-specific blockchains whose only job is to provide data storage. It's the most decentralized in terms of the nodes that are running it. The Nakamoto coefficient, a scoring, essentially denoting the number of economically independent entities that would have to be colluding or compromised before the blockchain started breaking, is by far the highest of any major blockchain, 5 times higher than the next. Ethereum's not actually on this graph because it's really very low. It's I don't know, 3 or 4 or something at the moment. It's also the most energy efficient. Now, energy efficiency, when we're talking about the relative sums of money that are going through, might not seem so important, but in reality it is. It's only by being energy efficient that we can reasonably hope to scale. The level of energy efficiency also caps the amount of transactions, or at least the cost of a transaction. We can never do, a Web3 system can never provide transactions for less than the energy cost, at least not long term. It achieves this through parallelization, distributing the workload across various different nodes on the network. This is in contrast to most other blockchains, which instead try to get every node to process everything sequentially, very notably Ethereum, but others as well. It shards data, but it also shards execution. It provides shared security, which essentially allows different economies to combine their security efforts and make the overall system, and therefore their overall security, much stronger at a relatively substantially lower cost. provides interoperability. This is important if we are to get various different economies interacting with each other. It allows the different blockchains to communicate and collaborate between each other by virtue of a common language. The common language in this case is XCM, cross-consensus message format. And as I mentioned, blockchain provides data availability inherently within the system. No additional costs are needed, no secondary token. Now that's Polkadot, but how are we actually turning Polkadot into the Web3 cloud? How are we developing this? Well, the first thing that you do when you're trying to build a cloud is you start off with a hefty machine, a powerful machine. The second thing you do is you make lots of these machines and connect them all to each other. We're not dealing with real machines, of course. We're dealing with these strange, decentralized machines. So we start off by creating a decentralized supercomputer. We have a name for this decentralized supercomputer, or at least the protocol that allows the decentralized supercomputer to manifest itself. It's called JAM. We also have mechanisms for taking multiple instances of JAM, connecting them to each other in some actually useful way, and then averting the need or averting the problem of having lowered security because of it. So JAM, what is it?